Hello, Algebra 1. This is Mrs. Brandt, and today we're going to talk about 7.1, which is our introduction to quadratics. We're going to talk about some key features. We'll talk about what a quadratic is, what it looks like, and how to find some of the key features. So you'll need your laptop if you don't have it, and if you have not printed out the notes, or if you didn't get them right before break, then please be sure to get that from Canvas. And if you have a printer at home, print it out. If you don't, then get some paper so you can write this down, please. So I want to talk about what a parabola is. I pulled up a browser for you, and we are going to look up parabola in real life. So you can see that I'm not just making this up. So you actually see parabolas all around you. You could here's several different examples for you. Hopefully you recognize this one, which is the St. Louis Arch, the McDonald's Arch, a roller coaster. We've got, the Eiffel Tower. There are lots of examples of quadratic functions, or what we call parabolas, in real life. And so they're all around you. We use them a lot, obviously, as you see here in architecture. So it's not just some made up thing that we have in math, this weird parabola thing. It's actually used in architecture because it's really strong. And so we use parabolas in architecture, we use parabolas in real life. That's why we're talking about them, because they're extremely common. So we'll get back to your notes now, and we're going to write some things down. So get with me. A standard form of a quadratic function is in this form: y equals ax squared plus bx plus c. Hopefully this looks familiar for you because we've just finished factoring lots of quadratic functions. So ax squared plus bx plus c, that's your standard form of a quadratic. When it's graphed, a quadratic function makes a U-shaped curve, which we call a parabola, which is what you saw me pull up on that browser a second ago. We're just going to talk about the equation first. So if I could get you to move down in your notes. We'll start by looking at the equation y equals 5x squared. Now I know what some of you are thinking. You're thinking, that doesn't have three terms like the one that we just looked at. You're right. So when you have a quadratic, and I know it's quadratic because it has a degree of 2, then we want to make sure we give it three terms if we don't see the three terms. I'm going to zoom in on this example just so you're aware. I'm going to zoom back out to the rest of the notes in a second. So let's take y equals 5x squared. We want to rewrite this so it has three terms, because right now, obviously, it only has one. So we're going to rewrite this as, right now it already has the a term, ax squared, but we also want to give it bx plus c. In order to do that, you have to have numbers in front of x. So we have to put a 0. Y equals 5x squared plus 0x plus 0. Now it's in the form ax squared plus bx plus c. And we can answer this part here, which asks for a, b, and c. A is a number in front of x squared, so that's 5. B is the number in front of x, so that's 0. C is the constant at the end, which is also 0. Now we're going to look at the second example here, y equals negative 2x squared plus 7. I'll zoom in on that one. Hopefully you notice that this one only has two terms, so we need to get three terms like we talked about in the last one. We need to rewrite it so it has three terms. Right now we have y equals negative 2x squared, so we already have the a term. If you notice though, we have the c term, so we want to get the one in the middle, the b, which has the x. So we're going to put plus 0x and then plus 7. Now that we've rewritten it, we can tell what a, b, and c is. A is negative 2, b is 0, c is 7. Last one, y equals x squared minus x minus 3. This already has three terms, so I'm not going to rewrite it, but we need to make sure we know what the coefficients are in front of each of those variables. There's a 1 here and a -1 in front of the b term. So a is 1, b is -1, you got to pay attention to the sign, and c is -3. We know that the a term is the number that's in front of, or the a is the number in front of x squared. So when a is positive, the parabola is going to open up. So this value, a is positive. And when you're positive, you smile. So this is a happy parabola here. On the other hand, if a is negative, so that first term, x squared, if there's a number in front that's negative, then it's going to open down, which is why we have a sad parabola. It's going to open up or it's going to open down. So those are some terms that you'll see us using here at on the back in a second. Let's talk about the vertex. When the vertex is at the lowest point, it is called the minimum because it's at the bottom. So it's going to look like this. So you have your parabola. If the vertex is at the lowest point down here, that's why it's the minimum, because it's at the bottom. If the vertex is at the highest point, it's called a, you guessed it, maximum. So I'll draw a picture of the parabola. Here's my vertex, the highest point, and here it would be a maximum, because it's at the top. The axis of symmetry is the vertical line of symmetry that passes through the vertex. And we have a formula for finding it, which we're going to use on the back in a second. It's x equals -b over 2a. That's what you see right here. We're going to talk about the y-intercept, which is the point where the parabola crosses the y-axis. It is the c value when it's in standard form, so we're looking at ax squared plus bx plus c. It's the constant at the end, and we want to write it as a point because it is a point. So it's going to be 0 because it's on the y-axis, comma, whatever the c value is. If you would flip your notes over to the back, now you should see some of the stuff we've talked about already. We see the parabola in blue. The axis of symmetry is going down through the middle of the parabola or the quadratic, and it's crossing at the vertex, which is at, in this case, a minimum because it's at the bottom. The parabola is crossing where you see that where you see that purple point, which we would call the y-intercept. It's crossing the y-axis there. And now we're going to talk about the x-intercepts, which is where it crosses the x-axis. You see those in red. So the points where the parabola crosses the x-axis are your x-intercepts. We have other names for these, and you'll see them coming up here more when we get further into our unit. Solutions, roots, zeros. Those are your x-intercepts, some other names for them. And then reviewing what we talked about first semester, we know that the domain is all the possible x values, and range is all the possible y values. When we look at domain, we want to usually look from left to right. When we're looking at range, we want to look lowest to highest. On our next two examples, you're going to find some key features, and we'll use our scientific calculator to help us find the vertex. So starting out with f of x equals -3x squared plus 6x plus 2 already has three terms. When you see f of x, it's just another way to say y, so don't be alarmed by that. Our a value is -3. Our b value is 6, and our c value is 2. Because the a value is negative, it's a sad parabola and it opens down. So it looks like this. The vertex will be at the top. So our vertex is a maximum because it's at the top. To find our axis of symmetry, we use x equals negative b over 2a. That's on the front of your notes. Negative b means to negate the b value. So it's going to be negative 6, since the 6 was positive, over 2 times a, which is negative 3. That's negative 6 divided by negative 6, which is positive 1. So our axis of symmetry is x equals 1. That is the line that goes through the vertex here. So this line is x equals 1. We're going to take that x value and use it to find the y value of the vertex, because we already know the x value of the vertex is 1. We need to know what the y value is. So we're going to go back to our original equation and we're going to plug in 1 into our function. I'm going to zoom in. We're going to input 1. So we want to know what is f when I plug in 1. Instead of putting x, we're going to put 1, and then we're going to evaluate. Now this is where, if you have your own scientific calculator at home or graphing, then you can use that. We're going to type this in exactly as we see it. So this part here is what we're going to type in on our scientific calculator, exactly as you see it. Make sure when you see a negative sign in front, you use a negative and not a minus sign. So I'm going to flip over to Desmos to use a scientific calculator there. In case you don't have one at home, that's what I'd recommend you use. If you don't have a scientific calculator at home, I would recommend you go to www.desmos.com. There's a really good one here. You want to use the scientific calculator, which you'll see in the bottom left-hand corner. All right, click on that button. It pulls this up, and we're going to type in exactly what we just wrote down, and I highlighted it on my page. Negative 3, and in parentheses 1, close it. To square something, you use this button, squared, plus 6 times 1, typing it in exactly as I see it, plus 2. If you can do this in your head, that's fine, but you have to be really careful when you do order of operations. Now if you look, it tells us that the answer to that is 5. If you did it on your own calculator, then you should have gotten the same thing. So that means when I plug in 1, I get 5. So my vertex is 1, 5 for the y value. So going back here, we know now that the y value of the vertex is 5. So I'm going to write that down right here. And you see it over there on the parabola. I've graphed 1, 5 for the vertex. Last thing, our y-intercept is the c value, which is 2. So our y-intercept is 0, 2. Moving on to our second example, you'll see it only has one term. We want it to have 3 terms before we start. So we're going to add on to this plus 0x plus 0. So now it has 3 terms. Our a value is 5, our b value is 0, and our c value is 0. Because our a value is positive, it's going to open up. It's a happy parabola. So it looks like this. And the vertex is at the bottom, so it's a minimum. Just like last time, to find the axis of symmetry, we do x equals negative b over 2a. That's going to be negative 0 over 2 times 5. 0 divided by anything is 0. So our axis of symmetry is 0. This is an equation of a line, so make sure you write x equals 0. Now we're going to find the vertex. We know, let's draw a little picture. The axis of symmetry here, this line is x equals 0. And we know that the x value of the vertex is 0. We need to know what the y value is. So we're going to plug in 0 into our equation. So I'm going to zoom in. To do that, I input 0 for x. Now I know we added 0x plus 0, but you only need the original equation right now. So 5 times 0 squared. If you need to go to your graphing calculator to type that in, type it in exactly as you see it. Sorry, your scientific calculator. 5 times 0 squared. 0 squared is 0, and 5 times 0 is 0. So you should get 0 when you type it in. That's my y value for my vertex. So y value for the vertex, I'll write it down, is 0. The c value for your y-intercept is also 0. So my y-intercept is going to be 0, 0. Last one. H of x equals negative 2x squared plus 10. This is missing a b term, so we're going to rewrite this. Let's rewrite it so it has 3 terms. H of x equals negative 2x squared plus 0x plus 10. Great. Now it has 3 terms. Our a value is negative 2. Our b value is 0, and our c value is 10. The a value is negative, so it opens down and looks like this. The vertex then would have to be at the top. So it's going to be a maximum for the vertex. Your axis of symmetry is this line that goes down the middle and makes a mirror image on both sides. X equals negative b over 2a to calculate that. B is 0, so it's going to be negative 0 over 2 times a, which is negative 2. 0 divided by anything is 0. So our axis of symmetry is x equals 0. That's the equation of the line that goes down the middle, because it's a vertical line. That means we know that the x value of the vertex is 0, and now we're going to plug 0 back into our equation. Take this 0 and plug it back in so we find the y value of the vertex. I'll zoom in. So I am doing h of 0, which should be replacing x with 0. You could keep the 0x term, but the original one, if you look here, doesn't have that. So I'm not going to use 0x. I'm just going to do negative 2x squared plus 10. Negative 2 times 0 squared plus 10. Well, this first part is 0. You can type this into your calculator if you'd like. First term will be 0, and then you add 10. I'll type that in the calculator so you can see it. So negative 2 times 0 squared plus 10 is 10. So you get your answer right here, and that's our y value for our vertex. Let's write that down here. Our y value for our vertex is 10. Ooh, ran out of room there. Because when we plugged in 0, we got 10. Our y-intercept, last thing, is 10. So our y-intercept is 0, 10. Okay, that's it.